Alright guys, today we're going to be looking at the Mole Lab here. This is what it should look like for you. First, a couple of things. I changed the words to the correct ones in the data table, but on these other pages you're going to have to change it. So anywhere that it says iron, you should change it to zinc. Anywhere that it says sucrose, you should change it to sodium chloride, and anywhere that it says sodium bicarbonate, you're going to change it to calcium carbonate. You can go ahead and play that back again for yourself if you need to hear that again. Alright, so step one, it asks us to weigh 3 empty containers because we won't be opening the containers of the metal, and we want to be able to subtract out the mass of the container. Alright, so this is where we're going: container 1, container 2, container 3. Alright, balance here. Alright, so we're putting container 1 on the balance. Gotta wait for that guy to turn on there. All right, so container 1, 8.105. Container 2, 7.585. Container 3, 7.955. Okay, so those are containers 1, 2, and 3. Again, rewind if you should need to go back and hear those again. They should be written on data table part 1 under containers 1, 2, and 3, and then you should calculate the average of the 3 containers. All right, next, it asks us to find the mass of each sample plus the container. All right, so we're going to start with aluminum. So mass of sample plus container for aluminum. There it is. Mass of container plus zinc. There it is. Mass of container plus copper. There you go. Mass of container plus tin. There it is. Okay, again, if you need to rewind and see those again, bring the video back. You need to subtract out the average mass of the container for the second one, and then calculate your number of moles for each one at the bottom of the page here. So subtract out the container, show your work for calculating the number of moles of each one of the elements here that are in that container. All right. All right, in part 2 here, it asks you to find the mass of 1 teaspoon of each of the following: water, sodium chloride, and calcium carbonate. All right, so we're going to start not with the water because then everything will stick to the spoon. Okay, so we're going to start with sodium chloride. All right, so I'm putting my weigh boat onto the balance here, I'm going to put 1 teaspoon of sodium chloride into the weigh boat. Oh wait, hold on. Before we do that, we need to hit 0 so we don't accidentally include the mass of the weigh boat. There we go. So mass of the weigh boat is now 0, adding in 1 teaspoon of sodium chloride. And there is our mass. Mark that down for the mass of 1 teaspoon of sodium chloride. All right. Next, we're going to do the mass of 1 teaspoon of calcium chloride. So weigh boat back on here, 0 that guy out. Get my calcium chloride here. I need 1 teaspoon. Add that into the weigh boat. There's our mass. Go ahead and add that under mass of 1 teaspoon of calcium carbonate. All right, and then last but not least, we need the mass of 1 teaspoon of water. So we're going to put our weigh boat back on here. We're going to hit 0. All right, then we're going to add in 1 teaspoon of water. All right, add that to the weigh boat. There's your mass. And you're going to put that under a mass of 1 teaspoon of water. Okay. And then don't forget to put in the chemical formula for each of those. And then you are going to use your data to answer these questions here, making sure to change sucrose and sodium bicarbonate to sodium chloride and calcium carbonate. Okay, so you're going to do all of these using the data here, 2 and 3. This is synthesis. Okay, so this question, you're just going to use starting with 1 gram. And in this one, you're going to start with 1 atom. And then in part 2, you're going to go back and answer questions about part 2. Please make sure you do not use the stuff from part 1 to try to answer these questions. This is from part 2. All right. And then that is all the data that you need to be able to make your calculations.